Best Practices webinar series, which is brought to you by the IDEAS Productivity Project funded by Exascale Computing Project of the U.S. Department of Energy. This is done in collaboration with the computing facilities at the Argonne, Oak Ridge, and Lawrence Berkeley National Laboratories. I'm Osni Marquez from Lawrence Berkeley. Ashley Barker from Oak Ridge, and I will be the hostess for today's webinar. So you want to be agile. Strategies for introducing agility into your scientific software project. And the webinar will be presented by Michael Hu from Sandia National Laboratories. Mike is a senior scientist at Sandia and the director of the software technologies for the Exascale Computing Project, as well as scientist in residence at St. John's University in Minnesota. Mike's research interests include all aspects of scalable scientific and engineering software for new and emerging parallel computing architectures. He leads several projects in this field, including Trilinus, which is a collection of scalable scientific software components, Mantivo, which is an open source portable mini applications and mini drivers for the co-design of future supercomputers and applications, and the HPCG, which is a benchmark for ranking computer systems. Mike's most recent interests are focused on improving scientific software developer productivity and software sustainability. As Ashley mentioned, all attendees have been muted. We'll be receiving questions through the WebEx chat and also the Google Doc, whose address we have pasted into the chat of WebEx. The webinar will have a break so Mike can respond to the questions that come in. Mike?
Thank you, Osni. Can you give me presenter? Thank you. Excuse me. All right, very good. Thank you very much for the introduction and for the opportunity to present to you today. Excuse me, I swallowed wrong. Excuse me. So first I want to acknowledge my funding sources, the Office of Science, Oscar, and the Exascale Computing Project, and then my employer, Sandia National Labs, and for the opportunity to conduct activities like today. I also wanted to alert you to a previous webinar I gave back in September of 2017. Not that you need to have seen it or understand the content from that, but just to say that this isn't the first conversation I've had in this setting with some of you at least. And if something's not clear, or if you want some more detail on some of the things I'm going to mention, it may be worth going back to that particular webinar, excuse me, to get some of those details. So a bit of an outline. First, I give some talks in this area, and I always try to give a characterization of my perspective. I am not an expert, so I'll tell you, my perspective on these topics. Then we'll move and discuss what I think is a decent characterization of Agile and scientific software. I want to give a brief recap of Kanban checklists and policies because, since I spoke about them back in September of 2017, I've only continued to grow enamored of them and learn and try to get more experience and apply them in a variety of settings. So I just can't give this talk without at least some mention of those topics. Then I'll talk about planning because I think that is an area in scientific software teams where I think there are opportunities for improvement based on my kind of survey of a lot of projects that I've seen and been involved in. And then I want to give you a couple practical techniques that I think could be beneficial to you as a team. Then I want to talk a bit about a strategy for introducing new practices and tools, and then wrap up with a couple of short topics on personal expectations. And then a new topic, at least to me, and as far as I know, new in generally, broadly speaking, is a notion of software science. All right, let's get started. So my perspective, I'm not really an expert in Agile software methodologies. I don't want to pretend to be, but I have had a lot of experience writing scientific software and have done so over a long period of time. So I've been able to see the benefits or negative impacts of decisions that we make and practices and things that we do or don't do as we produce scientific software. So I look at myself more as, say, a psychologist who enables conversation or tries to bring to light things that might work or might be worth focusing on. Also, when it comes to tools and processes, I'm more like a carpenter than an expert. I try things out and things either work for me or they don't. And if something does work, I like to share that. I get excited about it and want to share that with you. So that's my perspective, and it permeates the entire presentation. So if we're going to give a talk about Agile, I think it's worth talking about probably the most famous statement of what Agile is, and that's the Agile Manifesto. And you can go to agilemanifesto.org and see this page right here, the set of statements, the authors of it. And I don't know if you can tell so well, but there are four basic pillars, four basic statements: individuals and interactions over processes and tools. And in fact, the changes in font size are actually present on this website because they want to emphasize the importance of the things on the left versus the things on the right. Not that the things on the right are not valuable, but the things on the left are perhaps more valuable. They value them more on the left. Excuse me. And so I hope, if you're a scientific software developer, you will actually find the left side quite comforting and interesting and probably resonating with how you already behave. And so a part of my message is that as a scientific community and as scientific software developers, I think we're actually doing a lot of the things on the left. We do individuals and interactions. We like working software. We want customer collaborations. We want to respond to change. It's a part of our nature. As we do interactions, we go to meetings. We write things, software we want to use. We want to interact with people. And the results from one execution of our software may totally change the requirements and lead us in a new path because we discovered something new. However, I would argue that, at least in my experience, we're so focused on things on the left that we actually have opportunities to improve by doing a little bit more on things on the right of these four pillars. And in fact, I try to indicate by the size of the font where I think how much we actually emphasize the things on the right. I think we do, as a whole, do use tools, and we do documentation. We do, in some instances, follow a plan. I find very few teams, and I think this is not a bad thing, that have to worry about contract negotiations. So that's probably okay. But anyway, let me go on a little bit, and I'll come back and revisit this just a bit in a bit. Another thing I think that's worth keeping in mind is this quote from Fred Brooks, who's, among other things, has written the book, The Mythical Man Month, a well-regarded software engineering expert. He says that a scientist builds in order to learn, an engineer learns in order to build. And so basically a scientist or a scientist who's doing software is doing barely sufficient building in most instances, because the real objective is a scientific result that they're trying to get, to publish a paper, to get insight, to prepare for a meeting, those kinds of things. Whereas an engineer, their purpose is to build something. And so they do sufficient learning so that they can build what they want. So the challenge is that if we don't put enough effort into the building as a scientist or the learning as an engineer, we get poor results, poor software. All right, so I want to argue that Agile and scientific software are a combination worth pursuing. And so I'm going to try to bring out some relevant Agile attributes for scientific software teams. So there are a lot of different Agile methodologies. Probably the most common are Scrum. I'm guessing most people have heard of that. Kanban, extreme programming, less so in recent past, but still around. Scrum is certainly the most popular in industry. I think somewhere upwards of 80% of teams say that they use Scrum. What are some of the characteristics? iteration, incrementation, engaging users, hierarchical planning approach. And this, as I said, is quite consistent with scientific software development. Scientific software development attributes are things such as, for example, many of us have advanced degrees, often a PhD in a scientific domain. We are spending, as a rule, a lot of our time engaging in the community. Getting a PhD is not the end of your research career. It's actually the beginning of your research career. And you spend a significant amount of time keeping that degree fresh, keeping your stature in the community fresh. And we honestly have typically little time for cultivating advanced software practices if we're also serious about being an expert in the field, in our domain. And so we have this persistent choice that we have to make, better practices or newer results sooner. We need both to compete well, but it's a persistent choice that we're regularly making as we conduct our work. As our software becomes more interdeveloped, though, we have to have better practices because we tend, as we've seen, at least in my area, teams are getting larger, multiple teams are grouping together and coordinating with each other. And so these practices and how we conduct our work has an impact not only locally on our team, but other teams as well. Another aspect of scientific software is that we tend to have specialized expertise. And a lot of Agile methodologies, if there's a task on the list that needs to get done, there's usually more than one person who can take that task on. Whereas in a scientific team, there's often just one person who really has the skills to pull in a task. And that's just one example of how, if we're going to take Agile approaches and adapt them and adopt them on our scientific teams, we need to be cognizant of how our teams might be distinctive from, say, a typical team that might be using Agile methods and the literature that's been built up over time. All right, so that's a little bit of a characterization, I would say, of Agile and scientific software. And I want to go back to the Manifesto anti-themes, the things that were on the right. And so I want to talk just a little bit about stories for new processes and tools. I'm not going to spend a lot of time on processes and tools. In my experience, our community has really picked up on emerging platforms such as GitHub and GitLab. And because the tools that they provide are relatively easy to use and there's a lot of good documentation, I have seen teams rapidly adopt these platforms and the tools that go with them. And that's to great benefit for our scientific software teams. So in a certain way, I think we're doing quite well there. I have also, in my experience, seen really good documentation coming out of our community. I find regularly projects use Read the Docs. It's a platform for documentation development. Doxygen is embedded documentation for functions and methods, argument lists and things like that, and then regular publications. I do want to talk a little bit about lightweight design documentation because I think it's an opportunity that for some teams that they may not have considered, and I want to give an example of how I think that could be enhanced a bit without a lot of work and provide a lot of value. I'm not going to talk about contract negotiations. I think many of us we write funding proposals, but we don't really negotiate contracts, say, as what would commonly be done in industry. So I'm not going to touch on that. I do want to talk about following a plan. In a recent survey I did of a set of software teams, this is one area where I think there's opportunity for improvement. I saw in the survey that was conducted that quite a few teams, the most detailed description of the requirements of their product are in the funded proposal. And so to me, that says there's an opportunity to create further elaboration of a plan. What are the requirements? How might you design this thing? And so a lot of teams, if the survey results are accurate, are going straight from a funded proposal statement to writing and designing and working out the requirements in the software base. And to me, that says we have an opportunity for improvement. All right, so I just want to give a brief update. Maybe I'll pause, Ashley. Are there any questions that have come up, or Rosny?
Yes, there is one question, Mike. Is there one tool for Agile, or do I need more than one?
Good question. Yeah, there are lots of tools for Agile, and most people would want to use more than one. I think one of the common tool sets that's around are the Atlassian tools. So with the Atlassian tools, you get things like Confluence, which is a very nice online collaborative wiki development tool for creating, storing, and managing content. Lots of different kinds of content. For example, in the Exascale Computing project, at Sandia National Laboratories, we commonly use Confluence, and with great positive impact from that use. Another Atlassian tool is called Jira, which is an issue management software product that integrates nicely with Confluence. It is also, I think, overall a very nice tool. Although I think people who are use other issue tracking tools find that Jira can be a bit complicated to use. And so it's maybe not the first tool that you might use. Atlassian also just recently purchased Trello, not too long ago at least. And they also provide another set of tools. I think most teams that use Atlassian products definitely use Confluence and Jira. And those two tools provide a lot of the infrastructure that you would need to take on Agile development practices, including being able to do Scrum and being able to do Kanban as two Agile workflows. Another tool set that is much easier for a lot of teams to use is our GitHub and GitLab. And both of them also offer similar kinds of wiki or documentation type capabilities, and also issue tracking, and including lighter weight project boards that would allow you to do Scrum or Kanban. So those are three really common platforms that a person could get started with if they wanted to do Agile. Okay, should I continue on?
Yes, please, Mike.
Okay. Okay, I just briefly want to mention checklists and policies, just because I did speak about them back in September of 2017, but I continue to find them of such large value. And the two common checklists I use are a new team member checklist and a departing member checklist. Because I work with students a fair bit, and I'm getting new students in on a regular basis, and I have a master checklist that I use with them to make sure that they ramp up and they can see exactly what they need to do, and we can together see the progress that they're making on that. Also, students leave, and so I have a departing checklist for them. And then in the middle of that is a set of policies. And policies I find are useful in a variety of ways. One is it helps build a team understanding of what is expected in terms of behavior, and what best practices are expected. And so all of these are really important elements, I think, in any software team. And so I wanted to mention those again. I've also, since that talk, done a very lightweight resource that you'll see at the bottom of this, the 18 tools repository, that lay out some of the basics of what I find useful. Again, it's low bar startup, and there are some candidate checklists that you could use as a starting point, or at least get the sense of what I'm trying to say. And so I wanted to mention that these approaches continue to have value to me. I also wanted to mention the iterative work systems, Scrum and Kanban. And since September 2017, I have seen a lot of teams that have used Scrum with great success. And in fact, it's actually quite inspiring to see their effective use of Scrum. Primarily, though, in industry. As part of the Exascale Computing project, I have the great privilege of meeting with industry partners on our industry council. And so I've been able to meet a lot of software team leads, and their stories of how effective Scrum is for them are really inspiring. I've also seen at some of the labs that with teams whose team members are primarily there, on an everyday basis, kind of 9 to 5, Monday through Friday, methodical and pretty steady life, that Scrum can really be effective for them. Scrum is quite structured. I think most teams would practice what's called Scrum Butt, meaning they do most of what Scrum dictates, but they may slack off or omit, some aspect of the Scrum life cycle, work cycle. The key things are regular sprints and reviews, retrospectives to try to understand what went well, what didn't, the use of stories as a way of defining requirements, use of a backlog of set of stories, and there are very specific roles for the product owner, the Scrum Master, and more. And so it's quite elaborate, and it's probably not, at least in my experience, the thing that most people would want to pick up the very first approach they would use. Kanban is, I think at least, a little bit easier to take on. And the fundamental principle is limiting the number of in-progress tasks. You're trying to optimize flexibility versus swap overhead. So by focusing on, at most a few things that you're going to do, you allow yourself to retain that, that focus on a handful of things. And just, why wouldn't Scrum be so great and why would Kanban be better? And I try to give in the right there some list, right? That, Scrum is meant for a methodical development. It can support discovery-based work, but it's hard. It's harder. And so I have found in my experience, at least initially, that teams can benefit from doing Kanban in a way that is harder with Scrum. Here's just a basic Kanban board. Again, I'm not going to go into detail because I have spoken about this in the past. But if you had a set of columns, a backlog, which is any task that you think you might want to do, the ready column is any task that would be ready to be worked on because you know what you need to do. It's well scoped. And then the in progress column is the things that you're working on right now, and then the done is what you've completed already. And you can add other columns. I often have an in review column for things that I think are done, but I want to give to somebody else to take a look at. And then having a blocked column is nice for things that you were perhaps working on, but you can't work on now because you're relying on some other input or decision before you can pick it up again. So Kanban is, I think, very nice. So what I like about Kanban and why I try to advocate for it in this particular situation, if you're just getting started with Agile methodologies, is you can apply Kanban today to any existing project partially. All you have to do is really to start collecting and organizing the tasks, the things that you want to do, into the columns I just showed. You can use GitHub projects as a way of creating those columns and managing your GitHub issues. You can use Jira. It has an automatic generation of a Kanban board for Jira issues. And GitLab has similar kind of capabilities. They all support this column layout of work tasks. And even without managing your work, even without saying I'm going to limit the number of things I have in progress at once, just having the dashboard alone itself has tremendous value. It gives you a view of everything that you want to do and have done, and the things that you're working on. And so I use Kanban boards for a lot of different things, and I find them very useful. Probably the biggest challenge I have is the number of Kanban boards I have to manage. But it's okay. Each one of them is directly linked by a URL, and so I can go to it. I can have my boards up, all of them at once if I want to look at more than one of them. The hardest thing about, I think, Kanban boards, and for me when I have multiple, is just having a sense of how many things are in progress and how, when should I start limiting, because I don't have all of my in progress tasks on one list. But that is an issue, but I still think there's tremendous value. The other thing I find is running meetings using a shared dashboard is really nice. And then the last thing I wanted to mention is when you fall out of the habit of using your board. So I use boards, and every once in a while things get crazy or chaotic, or maybe I don't meet with a group for a while, and I fall out of the habit of using it. don't give up. That's not a reason to give up. It's just start up again. And I think that's a good attitude to take. All right, I'll pause here for if there are any questions.
No, Mike, you can continue.
Very good, excellent. All right, so I want to talk about planning because, as I mentioned, I think this is an area where, as a community, scientific software developers could do a bit more in terms of formal planning, objectively planning what we're doing. And I just bring up this quote from Dwight Eisenhower. Many people say this, I think, but it's attributed to him, that it's the planning process that's most important, that you tried out in your head a variety of approaches to solving the problem. You write down a plan, you start executing it, and shortly after you start executing it, it's no longer exactly relevant. But because you've explored other options, you have a mental model for adapting your activities to still benefit from the planning activities you did. Okay, I want to show two notional charts because I've seen this, and this takes years usually to play out. What I want to do is first talk about the code and fix development approach because I think it's pretty common. So what do we do in this? Well, so we start at the beginning of the project on the left, and the vertical axis is percent of effort that goes into the three types of activities. Well, so if we start off with an undisciplined project, we might do a little planning of what we want to do, but we really first start also writing code. We start, getting things going and computing results. And we didn't spend a lot of time trying to figure out, well, what are the exact requirements we need from our code, now and in the longer term. We didn't really think a lot about the design of the software. We just had this notion of what it should do. And so we started working on it. Now, as time proceeds, you didn't spend a lot of time in planning, which is okay. That means you get a lot of code out. You don't have to do a lot of recoding because it's a new effort, and porting to new platforms, you're working on it. So you're porting it to the platforms as you're writing the code. And so you don't really realize, any of the potential long-term challenges early on in the project. But as time goes on, you find that you have to spend more time planning because you didn't really architect the software, because new requirements emerge that you didn't anticipate. You're spending more time in planning just to simply change the code without totally disrupting what is done in the past. And then you also have to do recoding because you realize that some of your requirements force you to recode it in order to get those new features in. And then as you port it to new platforms, it takes a lot of effort because, again, you didn't, for example, isolate the portions of the code that are impacted by architecture, as an example. And then over time, and I've seen this happen, what happens is you spend so much time in planning, so much effort in recoding and porting to new platforms that eventually you realize, I can't use this code anymore, and you have to give it up. And that this kind of dynamic is not uncommon for undisciplined or unplanned projects. What I want to propose instead is that early on in the project, spend a chunk, a thin slice of time doing planning. And I'll show you two basic ways that you can get going on planning so that you can figure out, well, what are the requirements that I need from this product? And what is an architecture that will allow me to, say, do at least some number of iterations as we go to new platforms, and to support recoding of small portions, isolated portions of the software without having to re-implement or touch lots of lines of code as we go forward. And so with this approach, by doing some planning, yes, you've invested a fair bit of time up front in planning and doing design. And that's why it's such a big portion of that early phase is in the planning activity. And you're not getting that early visible progress in writing code, but in the long run, it will produce something that you can sustain much more easily. And integrated over a sufficient span of time will provide a lot more value than if you simply go right to coding with fewer design and planning activities, requirements, and design. Okay, So I want to talk now about two techniques that I think could be valuable to you if you're just getting started with Agile approaches. So just to make a distinction, Agile is both a methodology, something like Kanban or Scrum, but you also have to, so they both say require that you collect requirements and you analyze requirements, but then the how of that is a set of practices. And so I'm going to give you just a couple practices that I have found value, have seen a value in our community. And one of them is stories. And so if you haven't used stories before, they follow a pattern. I'm going to talk about two kinds of stories, user stories and a newer technique, what's called a job story, which I really like and I think may be appropriate for our teams. It's maybe a little bit more natural to us. And basically the pattern of a user story is you say, as a, I want, so that. So, as a particular kind of user, I want to, do a certain activity so that I can accomplish a certain objective or goal. And so it provides a nice pattern for you as a developers or your users even to describe what they want a product to do. And so it's a very lightweight method for defining, refining, and prioritizing tasks. And so it allows you to quickly and inexpensively describe what the product should do. And as I said, actually, let me highlight. So this is not something you put your blinders on and just do, right? These are techniques that work for some situations, may not work, may need some skill, and may need some adaptation in order for you to realize the values. So this is not a prescriptive technique. This is not something that has, say, proven value in every single instance. But I think these are techniques that can provide value to teams, and that's why I want to mention them. And then, as I mentioned, the job story is when, and so instance, what kind of situation I want to do something so that I can accomplish something. And so rather than being role-based, it is activity-based. And I think in some of our scientific software efforts, we don't have so many roles in terms of how the software is used. It's not a complicated architecture from the point of view of having lots of different actors or users that are accessing the product. But we often want to accomplish, a fairly sophisticated list of activities. And so that's why the job story can be particularly useful. So what are the phases of this in my experience? The first phase is just to generate stories and to brainstorm. Don't worry about the phrasing. Don't worry about the size or the details. I find that using a table like the one I just show on the screen here is a really good way to get people to put content in. And so so in my situation, you use multiple people who are trying to contribute to the stories, writing them. And so if you have a shared document, for example, a Confluence document, Google Doc can work if you want to use that, or even on GitHub with Markdown, you can do these kinds of activities. And so there are lots of ways to provide a shared document where people can collaboratively enter this content. Once you've collected a set of stories, whether they're user stories or job stories, you can begin the discussion. First of all, decide, are any of them out of scope? It was an okay idea, or maybe it just didn't really fit. And then you can then further go and try to clarify the stories, maybe make sure that everyone understands what the phrases mean, and then try to right-size them. And by right-sizing them, you want to put them in a scope of effort that can be accomplished over, say, a few weeks to a few months of time. At least when you're getting started, you don't. There are hierarchical planning techniques called epic story task, where you can get more involved in longer time, short, and very short times. But just to get started, scoping things like this is useful. And then prioritize and choose. And again, you don't need to order all the stories, but you just need to order the top set that you're going to work on. And then you can set the others aside and come back to them at a later time if after you finished the set that you selected. I have found stories not only to be useful in software development, but also in tool selection. For example, if you want to go out, I worked with a set of student teams recently, and I had them use stories to identify the features they needed from tools. And in particular, they needed to pick an IDE, an integrated development environment. They hadn't used one for C++ yet. They had been doing Java development until then. And one of the cool things that came out of this is one team stumbled upon a platform called Cloud9 from AWS, and it's really cool. It's essentially the Google Docs of IDEs. And so that was a really nice benefit that came out of that exploration phase by using stories. You can also use stories to define what you want in a team policy. What as a role on the team, what do you want? What do you expect? And so it helps to elicit the behaviors and practices that a team should sign up for. And then also for a group reorg, we recently reorganized the software technology focus area of the Exascale Computing Project, and we gave team members an opportunity to put in their stories to make sure that as we did the reorg, that we were addressing their concerns and their needs, what they needed from ECP software technologies. And so these stories have a wide usage as a way of gathering and organizing requirements. Then the second planning activity I want to just mention a bit is documenting design. And that's because if you make a mistake in a design document and somebody finds it, it's really as simple as just changing the document. If you make a design mistake and you write the software, you won't find out for months, maybe years, and then it's really difficult at that point. You have to either totally rework it or live with the flaw, and neither situation is attractive, and I've experienced both. So the point here is not to get into fancy design tools. There are all sorts of fancy ways to do design. And I'm not saying they're bad, but I'm saying that if you haven't done design as an explicit step in the past, you don't have to go immediately and start learning unified modeling language and doing class diagrams and interaction diagrams. All of that is good, but a small step that can help you is to simply write up what you are going to produce as a piece of software. And I use as an example, the Cocos kernels. They wanted to write a set of micro and batched BLAs, basic linear algebra subprograms. And they wanted to do that so it could be adaptable to a variety of computing architectures. It had to be high performance. And so rather than go off right away and start writing code, they took some time, 6 weeks, and they wrote a LaTeX design document with a few diagrams. And then they passed that document around to experts in architecture, experts in programming environments, users who needed to be able to use the product when it was done, and the rest of the development team that was working on it. And they made very significant design changes in that document, which if they hadn't done in the document, they would have written the code, they would have started, and it would have worked on the first target platform, but they would have discovered once they moved from multi-core CPUs to the GPUs that the design was not optimal. And so by putting this document out and getting it in front of people who had programming models and architecture expertise, they were able to detect flaws in the design that allowed them to redo the document, the design in the document, and then in a few weeks write that code. And that code is working really well now on these target set of architectures in a way that would not have been possible if they hadn't done this bit of documentation work. All right. Okay, so I've talked about Agile principles, the 4 pillars. I talked about how we do a pretty good job in most of the ones that we care about, how planning is something that I think as an opportunity we have as a scientific software community for improving the quality of our work. And now I want to talk a little bit about how you might introduce changes into your existing practices and processes and tools. And as this is just an adaptation of a Martin Fowler quote. Unlike industry, at least some industries I know, we do not tend to send our scientific software developers off for extensive training periods. I have a daughter who works in the software industry. She spent the first 6 months of her job going off to the company's software engineering training, where they gave her all of the background. Now, she didn't need to learn the domain. She didn't have a PhD that she had to maintain. She didn't have the conferences that she had to go to and papers to publish to make sure that she was competing well in her field. She just got to learn about how to do software. Now, we don't have that luxury for the most part on our scientific teams. Instead, what we have to do is we have to do improvements on our way to getting our work done. So we need to improve how we do our work on the way to getting it done. And so this kind of incremental introduction of improvements is, in my experience, the way that we can see value and still not have it cost too much as we produce scientific results. And so we have created within the IDEAS project what we call a PSIP process, Productivity and Sustainability Improvement Planning. And this URL down at the bottom, the PSIP's tools URL, gives this overview of how, again, it's nothing fancy, but it gives you some sense of what we're trying to do by first of all, snapshot, get a brief documentation of the current practices. In that description of practices, you can usually find a few things that could benefit from either a better process, use of a better tool, better methodology, and then make a short list of those things, and then create what we call a progress tracking card that lays out steps to improving. First of all, baselines your current practice, and then gives you points for improvements as you make them. And then you execute the plan to improve the practice or the process or the tool that you're using, assessing progress as you do it. And then once that's done, you repeat. And so this incremental approach we have found to be an attractive way of trying to get changes in our software teams done without disrupting too much our ability to still make progress in our scientific results. This is just an example of a progress tracking card where the scores go from 0 to 5. And so a team that hasn't done test coverage may have little or no independent testing. They may do some functional testing, but the users actually do it for them. And what they'd like to do is move in a steady way towards better and better both functional and unit testing, and see the value and the improvement as they go along. And that's the role of the progress tracking card. So we've done this with a few teams. MPICH team, they're the makers of one of the two main MPI implementations. And they realized they needed a formal, lightweight way of onboarding new team members. And so they created this progress tracking card for onboarding, and were able to successfully implement that up to the third step already. And then fourth one is work being done this year. Exalt is an effort, an application effort within the Exascale Computing Project, and they also introduced continuous integration and testing improvements to their product development, and again using these progress tracking cards. And so this has been a reasonable approach, again, fairly lightweight, fairly informal, but a way to get changes into your product. I think if you try to do too much at once, it really does put at risk your ability to get science done. And that's what we get paid to do. And so I think this notion of doing incremental and iterative improvement and taking on just the right size amount of improvement that still allows us to get our work done is a tunable way for us to succeed in getting better practices, processes, and tools into our software development efforts. I have two more topics I want to mention. One is personal expectations. So I found that I can lay out all of these big picture things and objectives to the software teams I work with, but I also felt like I needed to appeal to each person on the team, so that they felt a sense of ownership and a kind of call to being a better version of themselves. And so I think this is something else that is worth instilling into the teams that you have on your software, or the members of your team, your software team. And so just as an example, I stumbled upon this Canadian engineer's oath and this quote from the writer Rudyard Kipling. Each engineer, each Canadian engineer gets that iron ring that you see on the pinky finger of the right hand. There are legends of where it came from, a failed bridge. I don't think it's true, but it's still kind of fun to say. And so it's a general commitment on the part of each person who's an engineer that they will live up to a standard. And I'd like to suggest the same thing for our team members. And I want to do two concrete ways. One is, I think it's often the case, you look at GitHub projects and GitHub stats in particular, there's this heat map of how many commits a person has made if you look on their profile page. And I think that's actually the wrong metric in a lot of instances, especially for an undisciplined software team, because if the team is not disciplined, in other words, they're putting code into their code base and it's not well tested, it's not well documented, it's not well architected, then there's a problem, right? Because every line of code that gets injected into that code base just means there's more technical debt, meaning that somewhere in the future, because the job wasn't done right to begin with, somebody has to either do the job over or enhance it or fill in the gaps, or you abandon the work altogether. So I would instead, and you can do this, right? Our tools allow us, at least somewhat, and maybe some of it has to be done more manually or informally, but rank people or give people recognition for the people who write up requirements, who do analysis and design, even if it's simple. Someone who writes good GitHub issues, right, and tracks progress to completion, someone who comments on or tests or accepts pull requests or provides good content in response to user issues. To me, these are better metrics, and these provide incentive to team members to do a more holistic good job than just making commits to the repository. The other thing that I've done and created for my teams is I created a set of shelf magnets that I call productivity plus plus. But basically the notion is that I ask my team members, go get your cup of coffee, chat with somebody in the hallway, but when you sit down to do your work, after you've gone through the urgent emails, look at this card and ask yourself, is the work I'm going to do traceable? Meaning I can point back to an origin that this is something really important. Is it in progress? In other words, if I'm using Kanban, is this something I'm intentionally working on? Or am I doing it just because someone prodded me by a phone call to up the priority of something that's not so important? And then is it sustainable? Is it something that I'm proud of the work and that I think it will live as long as it should live? And then the fourth one is improved. Am I doing something on a regular basis to improve my skills? And so I hand these shelf magnets out, and I see them on the shelves of my work colleagues, so I hope that they're of some value. All right, one last topic I want to mention, and then we can move to questions. And I want to mention, because I think people on this webinar are scientists primarily, I want to mention a concept that I think is new. And this is the notion of what I would call software science, the science of software. Not the engineering of software, but the actual science of software. And I want to talk about a new department at Sandia that we're starting up that has a workflow associated with this. So this is a new software engineering and research department at Sandia in the Center for Computing Research at Sandia. I'm not trying to make a big deal about it, but I'm trying to convey that this is a concrete working model we're trying to develop in an organizational setting. There are three primary workflows in this department. There's a deployment, which you can think of as an IT type person. There is what is emerging as what's sometimes called a research software and engineering job class, and that's in the development phase. And then the third is this research phase, which we think is a new workflow. We're unaware of where applying science to software as a discipline is widely used. And this is kind of a pictorial version of that. So any individual on this team, is not slotted just as research or just as develop or just as deploy, but they work across the areas. And so it's a vertically integrated department that has deployment activities, software development activities, and research activities, which we're trying to grow. And it's this research software scientist that is really a new job type. And I just bring up a scenario that tries to evoke why we want to do this. And so, some years ago, computer scientists were not a common part of scientific software teams. Now, in my experience, they're widely available. And so before we brought computer scientists into our discipline, we had non-experts doing CSE work, and so they were less available in their own domain. The CS work took a long time compared to other work because they weren't experts, and we end up with suboptimal results, and we pay high ongoing maintenance costs. I would argue that we are in a similar situation right now. A lot of us don't have software experts on our teams, and so we do the work, but it's not, it takes us away from what we really want to do, our domain. It takes a long time to get it done, and we often get suboptimal results. And so what we're trying to do with this software science capability and bringing software experts into our scientific software teams is to rectify that kind of situation. An example of applying science to software teams is a recent paper done by a postdoc of mine, Reed Milovitz, and Elaine Rayburn, a colleague, a social scientist. And they're using essentially social science techniques, data gathering, analysis, and to create correlation between things like happiness and connectedness. That's one of the outcomes from this paper. And then as a science, then once you see correlation, that's not cause and effect, but you would design experiments to try to detect cause and effect. And so what I'm trying to argue here is that we can apply scientific techniques to better understand how we do research software, how we do scientific software. And I would like to propose that as a community, as scientists, we start using science to better understand how we do software. All right, let me wrap up, and then we can go to questions. So I think Agile for scientific software makes sense. If you look at the 4 pillars of the Agile Manifesto, gosh, they just resonate well with me, and I think they do with others as well. In fact, we're strong on that left side of the 4 techniques. And we can introduce formality in an incremental way, right? And we can use lightweight structured planning, Kanban, user job stories, basic design documents as a way to balance out a little bit on the right some of the things where we may have deficiencies. And then I argue that iteration and implementation are the way for us to do it, because we can't go and take 6 months or a year and become experts in software engineering or software development, because we need to keep going in our research efforts. We need to continue to publish and go to meetings and conferences and participate in the research community. And then finally, the last 2 things, calling out the best in our teams, articulate the mission of your software team. It may sound hokey, but I don't know. I think if you do it right, it can inspire people. And then I really like this notion, and I myself personally will continue to start looking at how can we apply a scientific method, the scientific method, to software to get a deeper understanding of how we can improve the quality of our scientific software. And I'll stop and thank you for your time and take questions.
Hi, Mike. We have a couple of questions here. The first one, would you consider Kanban a subset of Agile or simply a stepping stone?
That's a good question. I think in our community, because we have so many other demands on our time, and a lot of our work is interrupt-driven, our software work is interrupt-driven, that it's very difficult for us to do, say, a really formal sprint. We also tend to have smaller teams where it's not clear that you really need a product owner or a scrum master. And the teams that I've seen who have successfully applied Scrum, often they'll start with a coach, someone who comes in and coaches the team on how to play their roles and learn the Scrum workflows and methodologies. And so I don't know that Kanban is necessarily a step on the way to Scrum. It could be, and I think perhaps for some teams it is. I tell you, some days I wish we could do Scrum because I see that the tremendous value that it provides in terms of bringing a team together and getting them to focus and pull all in the same direction at the same time. There's so many positives associated with it. But when I look at all of the other responsibilities that we have as scientists and the interrupt-driven aspect of it and the eureka aspect of it, discovering something, and how do you put that in a sprint? I don't know. I guess I don't know. The answer is I don't know, but I'd be interested to see how things evolve.
We have more questions coming in, Mike. Can you briefly
Sure.
Can you briefly explain the new software scientist role again?
Yeah, sure. Sorry if I didn't do that more fully. So the notion here is we want to understand how to do a better job of scientific software. How do you make developers more productive? How do you make the software more sustainable and impactful? And so my argument is, well, that can be turned into a science problem. And how can you turn it into a science problem? Well, it's about a human system and the technology that the human system produces. We know how to study human systems using the tools of social science. We know how to do interviews. We know how to do data gathering. We know how to do information coding. And we can start to see correlations between, as I said, connectedness and happiness. The one outcome from the paper I showed you was there was a connection between people who felt connected to their team members and the happiness level that they had in doing their work. And now that's just correlation. So you want to turn that around and make it into a science question. Does connectedness lead to happiness? And so you would design an experiment to try to enhance connectedness on the team and see if that correlated to increased happiness. And so what we're doing is we're trying to take the tools of social science and turn them on, and you apply them to scientific software. That in a nutshell is what we're after.
Another one here, Mike. How big a team needs to be before all these extra efforts become worthwhile?
Yeah, that's great. Yeah, great question. Well, I think Kanban, a Kanban board is useful for a team of one. I use it regularly for managing my own personal tasks. And so at that level, low level, I think it's useful for a team of one. And I think Kanban it grows in value as you have more team members. It also grows in value, at least with distributed tools, for teams that are distributed or aren't necessarily on the same time schedule. I work a lot with students, but I also travel a fair bit. And so I use distributed tools to keep on top of the activities. And I use the Kanban board that I manage with my students' activities with as a way of having a dashboard on what they're doing. And they can communicate with me, I can communicate with them through the issues and through the board. And so that, again, can be done on teams that are small. I think in the literature, or at least the literature I've read, Scrum is useful for teams that are, say, size 5 to 9 dedicated team members. I think that's kind of the optimal size. Much less than that, you don't have enough people to see the value from it. Much more than that, you need to go to what is sometimes called the Scrum of Scrums. And it's a hierarchical Scrum structure, certainly beyond what I know well and beyond the scope of this conversation. But I think, even one person can benefit at least from some of the techniques that I've described here.
So, Mike, one participant is asking for the archive citation.
Yeah. So I think you have the slides, right, Osmi?
I have the slides, and then I'm going to paste into this.
Okay, great.
Yes. And another question, Mike. Yes, I'll paste the address of the citation to this question and answers. Another question, Mike. with the advent of using your concept of a computer scientist role in projects,
Yeah.
would the CS portion be more Scrum-based and the science end be Kanban-based?
That's a great question. Actually, I haven't thought about that. That's actually a cool thought. I hadn't thought. I don't know, but it's worth thinking about. I don't know. That's very attractive, actually. Thank you for the new idea, whoever said that.
Yeah, so then I think you'll have the opportunity to go through the questions again, and perhaps you can add something there.
Yeah, sure.
So I think with that, I'd like to thank you, Mike. And
thank you.
Yes, thank you very much. Thank you for all for joining us. And I'd like to take the opportunity to announce the next webinar in this series, Ashley, please. And what I'm going to do here is to share my screen. And so again, so you can give us feedback, please do so by using that link, Ideas Agile Survey. The slides and recording will be available next week, and we'll send the links to everybody who registered. And the next webinar in this series is going to be in about a month, on June the 12th. And it will be on modern C++ for high-performance computing. And Andrew Lumsdain from the Pacific Northwest National Laboratory and also the University of Washington will be the presenter. And the site is already open for interested people to register. Thank you all. Ashley, do you have any other final remarks?
Yep. Thank you all for participating. Another good webinar, and we'll hopefully see you next month. Thank you, Mike.
Thank you. Bye-bye.